Hello everyone, I'm Abir and this presentation is about free lossless audio codec or FLAC. So music has become a necessity in our daily life. In the field of music itself, newer technologies are being introduced every now and then. There was a time when people really cared about how things sounded, and even the lowest quality of tape recorder had an amazing engineering behind it. But now this is no more the case at all. Music is so available in the internet, but many of them are just pretty badly encoded and decoded, and it's mostly because of the lack of better encoder and decoder itself. But we still want to listen to music of good quality. Audio data requires compression for storage purposes. Now, we know that there are two types of audio compression, lossless and lossy. In the lossless compression, all the information about the audio is preserved, hence maintaining the original quality. FLAC is an audio coding format which uses the lossless audio compression and is the fastest and the most widely used one. So, what is FLAC? Well, FLAC stands for Free Lossless Audio Codec. It's something similar like a zip file, but FLAC is specially designed for audio files. So, if a file is compressed by FLAC and then decompressed again, you get back the original file without losing any information or quality. Not only FLAC is lossless, but it's also royalty free, which source code is also open for public too. What all of this means is that that you can use details and specifications of the format of any purposes without having to face any legal issues, and it's not restricted by any patents either, and it has an open source reference implementation. FLAC files are supported by various of devices and almost all of the operating systems. After compressing an audio file using FLAC algorithm, the compressed file usually becomes 50 to 70% of the original size, and in some cases even 80% of the original size. Compared to MP3, which is a widely used lossy audio coding format, this reduction can seem little, but to maintain the audio quality itself, this extra storage is gonna be really worth the while. Okay, I'm gonna talk about a short history of FLAC. FLAC first came into market in the year of 2001, when the first beta version came after having been developed since 1999-2000. Josh Colson is the guy behind the invention of this format. Over the last 18 years, there have been numerous updates. Almost all of these updates were all about bug fixing, new features, utilities, improvement of existing features, and so on. This process is still in progress. The last version of FLAC, which is called FLAC 1.3.3, was released in 2019. Previously, in 2013, when the version 1.3 was released, the development of FLAC was moved to zip.org. Now, the basic concept of FLAC. What FLAC does is it takes an original audio data which is really big in size, and it compresses it and makes it to a smaller size without losing any of the quality of the original file itself. And also, while decoding back to its original format, FLAC doesn't lose any kind of quality. The composition of FLAC. So the FLAC project consists of the stream formats, a simple container format for the stream, also called FLAC, a library of references, encoder, decoder, metadata interfaces, and it's called libflac. An object-oriented wrapper around libflag, and it's called libflag++. A command line metadata based on libflag to encode and decode FLAC streams. Metaflag, a command line metadata editor for FLAC files and for applying replay gain. Input plugins for various music players. and also OGG FLAC, an OGG container format for streaming. Since the FLAC format or any of the implemented encoding or decoding methods are covered by any patents, hence anyone can implement the specification of the stream format without a permission at all. The reference implementation is a free software. The source code itself for libflac and libflac++ is available under BSD license, and the source of FLAC, MetaFLAC, and plugins are available under the GNU GNU General Public license. The developers are encouraged not to implement copy prevention feature by FLAC project. Now I'm going to talk about the compression level of FLAC, just a brief explanation of it. The compressed file perfectly represents the original data itself. The level of compression does not affect the process at all, nor its speed at all, despite the fact that balance between speed and size is maintained in the compression process. The decoding process is always fast, no matter the size itself. The compression level and the parameter used in the process varies from 0 to 8. It's time consuming to encode using higher rates above the default level 5, while it won't gain any space saving at all. So here in this table that we got from Wikipedia, we can see the levels of compression options from it goes from 0 to 8. And if you check the zero compression option, if you try to compress a original file of 2.3 gigabytes, when we do it, when we compress it with using the first option, it will compress and it will go to for 1.435 gigabytes, and the ratio of the compression will be 70 just above 70%, and the encoding time is 1 minute and 29 seconds. While the decoding time is slightly less than that, is at 1 minute and 24 seconds. Now if you check the compression level 5, which is the default one, the original file will be compressed to a lot less, like it's gonna be only 1.34 gigabytes, so it's gonna be compressed at a lot without losing any quality at all. And the ratio of compression will be just above 65%, which is less than the zero compression option. And encoding time will increase a bit. It's gonna be like 3 minutes and 44 seconds. Yet the decoding time is still as low as it's possible, 1 minute and 36 seconds. But if we go above the default level, say for example 8, the original file will be compressed to 1.329 gigabytes, which isn't that much compared to the level 5 or below that. And the encoding time will be a lot. It's at 10 minutes and 17 seconds. But interestingly, the decoding time won't change at all. It's gonna still stay as low as possible at 1 minute and 40 seconds. So right now I'm gonna show some comparison between FLAC and other formats. So here we can see the original web file itself is the original audio source. It's a song of Bon Jovi, and the size itself is 53 megabytes. Now when we convert the the original file to FLAC, we can see that change of size, and it's at around 40 megabytes. And compared to that, we also convert the audio file to MP3, and we can see the size itself is even lower than FLAC. It's at whooping 177 megabytes only, but the difference will be in quality itself. This is the spectrum analysis of the original web file, and we can see that it goes up to 22 kilohertz. And if we check the spectrum analysis of FLAC file itself in the next slide, this is the next slide, we can see that this is the exact mirror image of the original file itself. So we can see it's still at 22 kilohertz without losing any quality at all, but it significantly lowered down the size of the file itself. Now about the interesting part, we saw that MP3 file it reduces the size to a significant degree, but we can see the quality change. We can see it's only at just above 15 kilohertz, and if we compare it to side by side with the original file itself, we can see that the MP3 file loses a lot of quality, and that's the best thing about FLAC encoding. Now to turn it around, this is this spectrum analysis is a decoded FLAC file, the decoded FLAC file that we got from the original file itself. We decoded back to its original format, and we can see that even after decoding back to its original format, it didn't lose any quality at all. It's still at 22 kilohertz, whereas this is on the right side. We can see the decoded MP3 file to original WAV file, and we can see the difference between the original file and the decoded to MP3 file to original WAV file, and we can see the quality change. We can see a significant quality change. And this is what FLAC format brings to the audio industry. We can easily reduce the file size without losing any quality at all, and also we can, if we want, we can just decode it back to its original file format without losing any quality. FLAC is one of the most efficient and wisely used codec. Being royalty free, almost all kind of hardware devices and softwares support FLAC, including card devices, DJ player, portable stereo, boombox, speakers, amplifiers, home media servers, portable handheld players, Blu-ray, smartphone, tablet, USB player, and so on. And also almost all of the operating systems supports FLAC. Here are some notable operating system that supports FLAC: Windows, Mac OS, Linux, Android, Unix, iOS, Palm OS, BSD, just to name a few. And to the conclusion, so to summarize all of the discussion made so far, it is now clear that FLAC is one of the best codec to encode audio sources in the view of its space efficiency and lossless quality. Its encoding decoding rate is the fastest. It is also a free audio codec in the fullest sense, because it's not restricted by any patents. FLAC streaming speed is also faster than most other audio formats, and additionally its error resistance and in any operating system makes it the most efficient codec. It possesses the wide range of software and hardware support, and developers are continuously making new versions of the format, keeping it up to date and making new improvement and bug fixes. So I want to conclude saying that although FLAC may cost a little bit higher than other audio files, it is always worth paying this extra money for better quality of audio and music. Thank you for your time. Have a nice day.